So dear students, we shall going forward to discuss the next chapter. The topic is box changing motion. The session outcomes of this session are the students will be able to classify the box changing mechanisms. Students will be able to discuss different type of box changing mechanisms with their merits and limitations, demonstrate various box changing mechanisms with diagrams, and students will be able to design the pattern card for pattern wheel or box changing mechanism. Automatic shuttle loom, various types of automations, automatic punch changing mechanisms we have discussed, and the various type of fillers which are used for the detection of the empty pan in the loom to activate the change mechanism, that also has been discussed. Now in this lecture we shall discuss about the box changing motion. The box changing motions are actually the shuttle changing motion. Shuttles are actually inserted inside the shuttle box, and that's why this type of changing mechanism, shuttle changing mechanism, is called as box changing mechanism. Though the box changing mechanism is older mechanism than that of the pan or bobbin changing mechanism, because the shuttle is a big entity with a heavier mass, so a higher amount of energy is required to change the shuttle from the shuttle box, and also extra manpower is required to insert a pan or bobbin inside the shuttle and then shuttle inside the box. Okay, still as this topic is in your syllabus, so you need to know the mechanism of shuttle changing. Okay, that is the box changing. The multiple box motion is necessary on a conventional shuttle loom where wave pattern is to be introduced across the fabric. So this was the main aim of using the multiple box motion. Multiple box motion, that means multiple shuttles are used in a multiple box. Okay, the looms are equipped with multiple box. Okay, maximum 8 number of boxes can be accommodated at the side of the loom, so that 8 different shuttle can be present in the box, and as per your wish you can insert any shuttle at the raceboard position for the picking or for the insertion of the weight. And all those different shuttle may have the different color of bobbin with it, so as a result weight patterning is possible. That means you can achieve some horizontal strip in the fabric of different color. Check and strip can be obtained in a woven fabric. So this is called weight patterning, and weight patterning may be necessary for weaving yarns of different color, count, twist or material. Okay, so you can vary or you can use different color of yarn or different count of yarn, twisted, low twisted, hard twisted yarn, and also different materials such as cotton and cotton blend, polyester, nylon, etc. and different type of blended yarn can be used for the picking insertion. So blended fabric can be prepared by using this weight patterning with multiple box motion. So each variation in the weight requires an individual shuttle, and there must be always one empty shuttle box in the system. So in either side of the loom there should be an empty shuttle box. So from the picking side there will be the full shuttle box, and either side or the other side you can say there should be the empty shuttle box, where after the picking the shuttle may be accommodated inside. So from that side again the shuttle will be sent to returning position. So use of multiple box reduces the speed of the loom by 10%. If you have the multiple box motion in a loom, then due to the this mechanism, there are some limitations in the speed. So the speed of the loom will be 10% lower than that of the single shuttle loom. Some of the common fabric which are produced from this kind of multiple box loom are wave stripe fabric, just I have talked about, check fabric, extra wave figure effect. You can produce extra wave figure effect by using different type of waved yarn. for the picking. Then crepe fabric, you can prepare a crepe fabric or crepe effect. Georgette fabric can be prepared. Double cloth, peak and certain varieties of towels, napkins and handkerchiefs also can be prepared by using multiple box motion. That's why the multiple box motion become very much popular in that time rather than using a single shuttle in a power looms. So classifications of multiple box loom. The multiple box looms can be classified in two types depending on the shape and the mechanism of the shuttle insertion. One is the circular box system, where there will be a circular magazine where the shuttles will be kept. 6 numbers of shuttle in maximum can be kept. There are 6 shuttle boxes, as you can see. Inside all those 6 shuttle boxes, 6 different shuttle can be inserted, and all those 6 shuttles may have the different type of yarn of different color, different count as per your wish. Okay, and at any time you can insert a shuttle as per your wish for the picking or the weft insertion. Okay, another type of box motion is the drop box motion. Okay, where the shuttles are arranged either vertically or in some cases horizontally, not in a circular way. Okay, the shuttle box are actually in the most common is in the vertically position. So there may be here it is shown that 4 shuttles are present in vertically, and the position of the rest board will be there. From the position of the rest board, which shuttle is present on the position of the rest board, that shuttle will be inserted for the picking. Okay, and at any time you can use or you can select any shuttle for the picking, and you can make those shuttle that shuttle at the rest board position for the insertion of the pick. So the drop box system is one type of rising and falling type. That's why it is called drop box, because the dropping of the shuttle from the vertical alignment can be possible. The boxes on one side, either the boxes will be only one side of the loom. So if there will be the 4 boxes at right hand side, then in the left hand side there will be a single empty box for the accommodation of those inserted shuttle. Okay, or there are boxes on both sides of the loom. So you may have the 4 boxes in the right hand side and the 4 boxes in the right hand side of the loom. So those type of looms are called 4x4 box motion. So that I shall again discuss later on. So shuttle boxes may be in the both side of the loom, so for the better versatility. The box motion can be negative or positive type. The box motion, that means the movement of the shuttle or the selection of the shuttle. Okay, that can be either negative type or positive type. Negative type means only the insertion of the shuttle in the insertion of the particular shuttle in the rest board position for the picking. That will be driven positively. That will be driven positively, or by some operation of the cam and crank mechanism. But the returning of that shuttle from the rest board position to the original box, that will be not controlled positively, that will be controlled by spring. So that kind of mechanism is called negative mechanism. That already, this type of negative mechanism already we have learned about in takeoff and let off mechanism, takeoff and let off mechanism. And in case of positive type of box motion, the whole movement of the shuttle inside the box and for the picking position, that will be controlled by positively from the cam and crank mechanism. Now circular box system. So circular box system is actually the older than that of the drop box concept. It is now obsolete. Circular box consists of 6 compartments of 6 individual shuttle revolve on a spindle. That I have mentioned in the previous slide. There will be a spindle. Okay, on the spindle there, this is a circular way, or you can see a cylindrical way the shuttle boxes are present. This type of circular box systems are available in Hattersley and wide circular box motions, circular looms, and this kind of motions is nowadays obsolete, that already I have mentioned. The presence of over-peak stick cause difficulty of applying automatic wave replacement device on an automatic loom. So basically this type of circular box motion is more familiar with the over-peak mechanism. Now over-peak mechanism is having many limitations that already we have studied in your FM2 lectures. Okay, so the over-peak mechanisms are not very much suitable for high speed manufacturing. So that's why as this circular box system is more familiar with the over-peak mechanism, it is not very much desirable, becoming obsolete because they can work in an over-peak and loose reed motion. Also, the circular box system is suitable for working in a loose reed mechanism. So that's why this particular circular box system is now becoming obsolete. They are suitable for light and medium weight fabric. This is another limitation. For the heavyweight fabric, this kind of box motion is not suitable. Random selection of shuttle is possible from the magazine. Random selection of the shuttle for the peak insertion is suitable. Is possible from the magazine. This is one of the advantages, you can say. The speed reduction is necessary. This is one type of demerits. Okay, as I have mentioned, the 10% reduction of the speed is required if the circular box motion is fitted with the loom. Special care is required to minimize lashing in. Lashing in is the extra length of the yarn which is present after a peak insertion and after the beat up. Okay, the extra length you can see from this image, from the selvage and to the shuttle eye, the extra length of the yarn will be there after completion of the peak. Okay, this amount of extra length after cutting by a particular cutter, okay, that will hang from the selvage position. This particular extra length of the yarn may be inserted inside the shade, and that will be a defect which is called as lashing in. So controlling of lashing in is very crucial task for in this type of circular box motion. Okay, because the extra length in this way always will be present in the circular box motion, and when the box will be moving, okay, one shuttle is moved out of the space and new shuttle is now coming in the position for the peak insertion. So this length of the yarn will be higher, okay, because the shuttle is now change its position. As much as many as rotational movement will be there on the creel or the magazine of the shuttle, as high as will be the length of the yarn which will be wrapped over the creel, and that will be the wastage of the yarn also and causing a serious lashing in. Now this is the pictorial demonstration of the circular box motion. I shall not mention the detailed mechanism here, but this mechanism you can study from the book, how the circular box changing motion is effected from the bottom shaft. The bottom shaft is here. V is the bottom shaft. You know, for a full rotation of the bottom shaft, there will be the two peaking or two peaks are inserted. Okay, one rotation of the bottom shaft will insert two peaks in the loom. Okay, so when the bottom shaft will rotate, there will be a cam. Due to the action of the cam, there will be the rotation of the pattern wheel or pattern cylinder, which is shown here. This is the pattern wheel. Okay, on the surface of the pattern wheel there are some tooths, and the pattern wheel is rotated by the action of the bottom shaft. Okay, and over the pattern cylinder or pattern wheel, there will be a pattern chain. Okay, the pattern chain, the patterning on the pattern chain is actually done with respect to the design of the fabric. Whenever there is a requirement of the change in color or change in weight, there will be a hole on the pattern chain, and on that hole, the small stud P of the tumble lever will be inserted. As soon as the tumble lever will be inserted, it will depress, or it will depress this bell crank lever N, and which will engage this hook, which is called the upright catch. Okay, this will engage this hook, and as a result, the motion will be effected here in this circular box screw or the cylinder. Okay, to rotate one movement of the box, so that one box will be at the position of the race board for the picking or for the insertion of the shuttle. So the total mechanism you can understand from the textbook. Okay, that the study material I shall provide for your study, and during your practical classes, this mechanism can be demonstrated in the institute. So now next come to the drop box system. The drop box system, where the shuttle box are arranged vertically at either the left hand side or right hand side of the loom. Okay, here 4 types of drop box motion are shown pictorially: A, B, C, and D. A is the 2-into-1 drop box motion. 2-into-1 means two boxes will be there at the right hand side, and one box will be there in the left hand side. Where 4-into-1, 4 boxes at the right hand side, one box at the left hand side. 2-into-2, both sides there will be 2 boxes, and 4-into-4, which is more versatile one, where 4 boxes will be there in both sides. So you can see, in case of 2-into-1 drop box system, 2 shuttle can be accommodated, or 2 different color can be inserted in the fabric. Okay, but it is very important to understand that when a shuttle of a color, suppose the red color and blue color, 2 color yarns are there in 2 shuttle. When the red color yarn is inserted, the shuttle will be from this right hand side to the left hand side, and the same shuttle will then come back again from the left hand side to the right hand side. So 2 peaks are inserted in the fabric. 2 peaks of red color will be inserted in the fabric. Then the blue color may be inserted, and when the blue color will be inserted, the blue color shuttle will come from the right side to the left hand side, and again from the left hand side to the right hand side. So 2 peak of the blue color will be inserted. So in this type of drop box system, when there will be a single shuttle box at the left hand side, so minimum 2 peak are required to be inserted, because this is the limitation. You cannot have in a fabric red and blue alternate peak of different weight. It is not possible. Okay, you should go with the couple of peak. Okay, but in case of 2-into-2 drop box motion, in both sides there will be the shuttle boxes, and in the left hand side there will be always a box will be empty, because where you need to accommodate the shuttle which is coming from the right hand side. Okay, when the shuttle blue and white, when the blue and red, so when the red shuttle is inserted from the right hand side, it will be accommodated in the left hand side in the empty shuttle box. Okay, from then empty shuttle box, now in the left hand side you have 2 color. Okay, one is the red and another is the green. Okay, so you have 2 color. So maximum in a 2-into-2 shuttle box motion, you can insert maximum 3 color. Okay, red, blue, and green. Okay, for example, so 3 color can be inserted, and in this type of 2-into-2 box mechanism, you can have a single color, alternation of single color of wave. Means you can insert a single peak of the red, then single peak of the green, then single peak of the blue. Okay, it is not like that the mandatory 2 or the couple of peak of the same color is required to be inserted. So 4-into-4 box mechanism is more versatile, but maximum 7 color can be inserted from the 4-into-4 box mechanism. So drop box unit operates on a rising and falling principle. A loom with a 2-box unit at one side and a single box at the other side of the loom is generally described as 2-into-1 box loom. One of the limitation is that only one box movement is possible to move from the box in use to either of the adjacent box only, which limits 3 color in sequence. Already I have mentioned the size of the shuttle compartment is fixed, and therefore any adjustment of worn out shuttle is difficult, because the size of the shuttle compartment, the shuttle box is fixed. So that's why if any shuttle is broken, then it is very difficult to adjust inside the box. Then there will be the faulty movement of the shuttle, and there will be the damage in the cloth as well as damage in the machine parts. So it is very important to make the good quality shuttle, and so that it can be used for long run without damage. And that's why the good quality shuttle, and the material of the shuttle, that the wood, quality of the wood, that is a particular or peculiar type of wood, and which is very costly and rare available. So that's why this type of drop box motions are becoming obsolete due to the requirement of the costly shuttle. More number of shuttles are required, whereas in case of bobbin change mechanism, shuttle will be the single one, but pan or bobbin will be changed. So there the punch changing or bobbin changing mechanism is less costly in terms of material cost. But the drop box motion, where the more number of shuttles are required, that is costly in comparison to the material cost. And 2 into box motion, also known as wave mixing motion, because this motion, this 2 into 1 box motion, was actually invented for the mixing of 2 different waves. Okay, for example, you have the gray yarn, gray cotton yarn, but there may be mixing of 2 different fiber. Okay, or your yarn is prepared with 2 different fiber. If you insert the yarn of the same fiber for a prolonged duration of time, okay, say 200 peaks, and for the next 200 peaks you have used another part of another variety of cotton fiber, then there will be the clear shade variation during the dyeing. Okay, so that's why it is required to mix the 2 quality of the yarn, though they are the gray yarn, but as the yarn are made of different quality of the fiber, it is required to mix the both fiber, okay, in the fabric stage during the manufacturing of the fabric. So that type of wave mixing is possible in 2 into 1 box for alternation of the 2 different quality of the gray yarn. 4 into 1 drop box motion on the loom is the most common type of wave patterning to give a greater scope in cloth designing. So most common the drop box motion which is used is the 4 into 1 drop box motion, because it is used for the wave patterning. Okay, that means you can insert 4 different color or different pattern you can create on the fabric. That's why this is more common in the automatic shuttle loom. A loom having multiple box unit at both sides with 2 into 2 and usually 4 into 4 can be used as peak and peak system or peak at wheel system. So the box motion with the 2 into 2 or 4 into 4 boxes are called as peak at peak system or peak at wheel system. Peak at wheel, that means as your wheel, as your wish, you can insert any color anytime for the wave insert in the fabric. So this is the spectacular advantage with the 2 into 2 and 4 into 4 machines, drop box machines. That's why they are called as peak at wheel system. The insertion of the single peak or any possible number of time from the either end of the loom to introduce any number of peaks, so that odd or even number from the same shuttle is known as peak at wheel. So this can you understand why the 4 into 4 or 2 into 2 drop box motions are called as peak at wheel mechanism, because you can insert any color at any time, okay, for any number of picking cycle, odd or even number, all these are possible. The much versatile the system it is. Now wave mixing mechanism, which is generally known as 2 into 1 shuttle box mechanism. The mechanism is just, I shall give you brief detailed mechanism. You can go through from the book again, because it is not possible to discuss the detailed mechanism in this way in the class. It is your self understanding by going through the books. So here in brief I shall discuss. Here on the bottom shaft there will be a disc. The disc is having teeth for a particular length. Okay, shorter length there will be the teeth, and this disc is actually engaged with an eccentric. The eccentric is having 1/4 toothed. Okay, then there will be the plane surface, then again 1/4 toothed. So in this way, this eccentric will be rotated when the disc will rotate itself. When the teeth of the disc will engage the eccentric, the tooth of the eccentric, then the eccentric will have a half a rotation. Okay, again after the half a rotation of the eccentric will slide over the disc because there will be the no teeth. Now it is important to understand the function of the disc and the eccentric and their rotational movement for the change mechanism. A two-position eccentric governs the position of a fulcrum lever. So this is the fulcrum lever which is fulcrumed at F. The position of this fulcrum lever is governed by the rotation of the disc and the eccentric. If the connection of the crank lever to the eccentric is in its highest position, okay, this is the crank lever. Okay, if this is at its highest position, then the bottom box level with the rest board. The bottom box, this is the bottom box, number 2, and number 1 is the top box. Okay, when this crank lever is its highest position, then the bottom box will be at the level of rest board. This is the level of rest board. From the level of the rest board, the picking is possible, or the picking action or the shuttle can be inserted into the shade for the picking from the rest board only. That's why the shuttle which is required to be inserted inside the shade, that should be kept on the level of the rest board for the picking action. But if the eccentric is turned to a half a revolution, if this eccentric will turn to half a revolution, the lever will be lower and the box unit will be lower to position. If the eccentric will rotate, it will bring down this lever and as well as the crank lever. Okay, then the top box level with the rest board. So at that position, the top box that will be at the level of the rest board, and then from the top box or the number 1 box, the picking can be done. The motion is driven by the bottom shaft, so that the eccentric is driven through half a revolution once every 2 peak to give a 2x2 wave replacement sequence. So as already mentioned, the disc which is mounted on the bottom shaft, and you know the single revolution of a bottom shaft will affect 2 peaks. Okay, 2 RPM of the loom. So that's why the half a revolution of the eccentric will give 2 peak, and every 2 peak to give a 2x2 wave replacement sequence. So this is the wave mixing mechanism where the 2x1 box motion is equipped with, and this type of mechanism is useful for 2 color weft, or when the mixing of grey yarn is required. So most versatile one, or you can say better versatile one, is the 4x1 drop box motion. So this kind of motion is available with Crompton and Knowles loop. So that's why this is also called as Crompton and Knowles 4x1 drop box motion. So as name suggests, there will be the 4 box in the left hand side, or here you can see in the right hand side of the loom, and 1 box in the left hand side of the loom. So there are the 4 boxes, 1, 2, 3, 4. 4 shuttles can be equipped with in 4 box. Okay, and in the left hand side there will be the empty box. So as there will be the 4 box, so maximum 4 color can be inserted, okay, for the patterning purpose. So now in this particular mechanism, here you can see there is the E. Okay, E is the bottom shaft. On the bottom shaft, 1 driving gear G is mounted, and the driving gear is toothed 1/4, then 1/4 a plane surface, then again 1/4 two-thirds, then 1/4 again plane surface. And this driving gear will engage one rear eccentric A or one front eccentric B. A and B are named as rear eccentric or rear gear somewhere, and B is mentioned as front eccentric or front gear. Okay, the rotation of this driving gear will either engage rear eccentric or front eccentric separately or simultaneously. So this particular mechanism, this particular rotation of these driving gears, rear eccentric and front eccentric, will affect the movement of the shuttle box up and down, so that the desired shuttle box or the desired shuttle will be coming at the level of the rest board. This is the position of the C, which is the position of the level of the rest board. The shuttle which will be there on the rest board, that is inserted into the shed for the picking purpose. Okay, so at the starting position, the back eccentric or the rear eccentric is at highest position. Okay, this is one example we are looking on to understand the mechanism. Suppose at the starting position, the back eccentric or the rear eccentric is at the highest position and front eccentric is at lowest position. At that moment, the top box is at the level of the rest board. Okay, this is the current situation which is shown here. The top box which will be at the level of the rest board. Now the shuttle which will be there inside the top box, that will be inserted for the picking. Now the front eccentric is driven through half a cycle. Now from the starting position, if the front eccentric is driven through a half a revolution by the driving gear, then one box movement is possible. Okay, this is important to understand. Then only one box movement is possible. If back eccentric is driven through half a revolution, then two box movement is possible. These levers and the crank mechanisms are arranged in such a way that if the front gear will move half a cycle, then one box movement is possible. If the back eccentric is driven through half a cycle, then two box movement is possible. Okay, if both the eccentric moves in opposite direction, both the eccentric will move in opposite direction. For example, eccentric A, the rear eccentric, will move in clockwise and eccentric B in anti-clockwise direction, then the three box movement will be possible. And if both the eccentric will rotate in the same direction, then one box movement is possible. Okay, so these are the movement of the box possible by selectively rotating the eccentric A and eccentric B by rotating the gear G. Okay, so in this way, as per your wish, you can rotate these two eccentric either separately or simultaneously to move the box. Okay, there are four boxes. If you want the first box to be at the rest board position, then that will be the starting position. Now in the next picking cycle, if you want the second box should be on the top or in the rest board level, then one box movement is required. So in that case, you need only the front eccentric to rotate half a cycle. Then if you want the third box at the rest board position from the starting position, then you need to rotate the back eccentric half a revolution, so that the third box will come directly at top at the rest board level. And from the starting position, if you want the fourth box at the rest board level, then you require three box movement. So at that time, you need to move both the front and the back eccentric in opposite direction. Okay, so in this way, one can select any box anytime to bring it to the level of the rest board for the picking. So the selection of the color can be possible. So maximum 4 colors can be used. But one of the most important limitation is that the shuttle which is selected for the picking, or which will be at the level of the rest board, the shuttle will be inserted from the right hand side. The shuttle will be after picking, the shuttle will be there in the left hand side in the shuttle box. In the left hand side there will be the single box. Okay, then the same shuttle need to be returned from the left hand side to the right hand side. So two peak of the same color always will be there. Okay, from left hand side to the right hand side and right hand side to the left hand side. Then the changing of the shuttle can be possible. So a couple of peak of the same color always will be inserted by this type of 4:1 drop box motion. So this is very important information to understand. So now this is one practical example of how the pattern card can be prepared based on the pattern or design which is required to produce in a fabric. Suppose you have a fabric design of 42 peaks per repeat. Okay, 42 peaks repeat is there, and on the 42 peaks repeat you have 2 peak white color thread, then 4 peak red color thread, then 2 peak white color, then 8 peak blue, then 4 peak yellow, then 10 peaks red, then 4 peaks yellow, then 8 peaks blue. So in this way one design pattern is there you require to produce in a fabric. So that means in the first 2 peaks there should be the insertion of the white thread, then the next 4 peaks should be the red thread, then the next 2 peaks there should be the white thread, so on. So here you can see there are 4 colors. Okay, white, red, blue and yellow. These are the 4 colors. So 4 colors are there, so you require a 4:1 drop box motion to produce this pattern on the fabric. So based on this design you need to require to prepare the pattern card which will be there on the pattern card or pattern chain, which will be there on the pattern wheel, and the selection of the peg is required based on the pattern this pattern chain, so that the proper shuttle is selected, and this is bring to the rest board for the picking. So here there are some principles that you need to know to design this type of pattern. So here at first you need to know which is the least popular weft. Which is the least popular weft means the color which is inserted a minimum number. So you can see white color 2 peaks are required in the whole pattern. So white color is the least minimum weft. So white color should be kept in box 1. Okay, because the least movement is required for this particular box. So that should be in the starting position. So that is the white color shuttle should be kept in box 1. Okay, then the second most popular weft, which is the red color, you can calculate. The red color require 4, 10, 14 peaks are from the red color. The red is the second most popular weft, that should be kept in the second box. Then the most popular weft is blue. Blue requires 8 peak plus 8 peak, 16. The 16 peaks are from the blue color. So blue colors should be kept in third box, because bringing the third box to the rest board position, most of the energy and power is required. So once it will be transferred to the rest board level, then most of the peak should be effected from this color only, so that the less amount of movement of the shuttle box is required. And the third most popular weft, yellow, which should be kept in the fourth box. So in this way you need to select the proper color for the proper box positions. Okay, so this is the order of the weft in boxes that you need to decide in this way. So after that you need to go for the making of the pattern chain, okay, for the 42 peaks. So here you can see the selection for the drive to the back eccentric is the right hand side hole, and the selection of the drive to the front eccentric is the left hand side hole. Okay, these two holes you need to define at first, which is for your back eccentric and which is for your front eccentric. Now for the 2 peaks wide, okay, this is the starting position when, okay, there will be no selection. Then the next is the 4 peaks red. So for the 4 peaks red color is there in the box 2. So 1 box movement is required. So for the 1 box movement, you require half a revolution of the front eccentric. So the selection is given to the front eccentric. The whole is become shaded. Okay, this is blackened. The front eccentric, because a single box movement will be affected when the front eccentric is making half a revolution. For making the half a revolution in the front eccentric, the selection is being made on the front eccentric. Okay, then there will be again 2 peaks wide, there will be no selection, that will be the starting position. Again there will be no selection. Then the next 4 peak is blue color. Okay, now blue color, which is there in the box 3. So from the box 3 level to the restboard position, 2 box movement is required. So 2 box movement is possible when the rear eccentric have a half a revolution. So you can see for the 8 peaks blue color, okay, all the rear eccentric positions have been shaded for the selection and movement of the rear eccentric half a revolution. Okay, then 4 peaks yellow, 4 peaks yellow. So 4 peaks yellow color is required. Yellow color is kept in the box 4. From the box 4 to restboard position, 3 box movement is required. For the 3 box movement, you need to rotate both the rear and front eccentric in opposite direction. So for the 4 peak yellow color, okay, all the selection for the front and back eccentric have been made. Okay, then again 10 peaks red color is in the second box. So 1 box movement is required. So all the front eccentric has been selected here. Then for the next 4 peak yellow color, again the 3 box movement is required. All the front and back eccentric has been selected. Then the 8 peaks blue color is kept in the box 3. So 2 box movement is there. So for all the back eccentric has been selected. In this way, the pattern chain is required to be made. Okay, for the proper selection of the boxes for the insertion. Hope I can give you the understanding of this pattern making. So you can again go through the book. This particular topic is available in the book of Marks and Robinson. There you can study in detail, okay, about this pattern chain making. This topic may be a very interesting topic for the practical experience also. So let's see how the practical classes can be conducted based on this subject in the institute laboratory. So now next topic is the peak at wheel motion, the motion that is required to activate multiple shuttle boxes arranged on both sides of the loom, either 2x2 or 4x4 box motion. They are called as peak at wheel motion. I already mentioned if there are 2 boxes both in left side and the right side of the loom, then you can choose any color anytime from any of these 4 boxes and you can insert that color. So but here the limitations with the 4x1 or 2x1 box motion, that is the couple of waves of same color to be inserted on those cases. But here you can select a single color picking and you can design your pattern based on the single color wave. Okay, that is possible here. Okay, that's why this motion is called as peak at wheel motion. It is possible to insert different color wave turn any number of times from either end of the loom. This is the most spectacular advantage. This is the wheel, your wheel. Okay, that's why it is called peak at wheel motion. In a 4x4 box loom, it is possible to use up to 7 colors from the 7 different shuttle, because one box you need to keep empty, because otherwise the shuttle which will be inserted from one side, that should be accommodated in either side or other side in the empty box. So one box always you need to keep empty in the other side, so that after the insertion of the shuttle that can be collected from other side inside the empty box. That's why maximum 7 colors can be used in case of 4x4 box motion, and in case of 2x2 box motion, maximum 3 color can be inserted. It is always necessary to keep one empty shuttle at the end side of the loom. So this is all about your box changing motions and mechanism in brief. So in detail you can go through in the textbook. I think the topic is interesting to you now. So let's stop here. So in the next class I shall start the teleweaving. Happy learning.